Welcome to Study Loop.
In this problem, you are given an equation asked to identify the unknown variables and to describe the situation that you are seeing with these equations. So on the left-hand side, we do have the application of the thin lens equation. So they're using S prime as di, which is the distance of the image. And so our distance of the object is 4 meters. The fact that we have a positive value here means that our focal length is 0.1 meters. Again, because it's positive, this tells us this is a concave lens. I'm sorry, convex lens. So right now what we're looking at is a convex lens with a focal length of 0.1 meters and a distance of the object 4 meters away. We can solve for SI or DIs. They're using S prime to represent DI. We can use this to calculate that S prime, which gets us 1 over S prime equals 1 over 0.1 minus 1 over 4, and then S prime by itself is 1 over 0.1 minus 1 over 4. So this gets us about 0.1 meters as our distance of the image. And if we use that information, we can calculate the height of the image, which is h prime on the other side. So this is the application of the magnification equation. Often you'll see this equation written as just h. I typically like to write HO. This will be S prime over S. I'm going to write O just to clarify. And they're solving for h prime, which is the height of the image. So they're bringing HO up, which means the height of your object is 1.6 meters. So this thing is 1.6 meters tall. And then the image that's being produced over here, the image that's being produced is 0.1 divided by 4 times 1.6. So h prime, or height of the image, is negative 0.04. The fact that you got a negative value here tells us that it is inverted, which means it is real. So this is an inverted real image. And we don't really know the units because the units of this would have canceled out. And so this is just negative 0.04 units of whatever the height of the image was measured in, probably meters.